What do you say? We have to find
Sir,
the speed.
sir, the motion is non-uniform, no, sir?
Yes. Speed is increasing. So non-uniform. Okay. So for a non-uniform motion, there is a tangential
Sir?
acceleration. There is a radial acceleration. Both will be there.
Yes, sir.
So use this equation, that is acceleration mu g should be equal to resultant of this one square root of v square by r whole square plus a square. Here a is tangential acceleration, and from here you try to find out v. Try to find out v from this equation. Okay, this is the formula, and find out v. Now if you simplify this, mu square g square minus alpha square into r square whole power 1 by 4 you should get. The next, a block of mass m is kept on a horizontal roller. The friction coefficient between the roller and the block is mu. The ruler is fixed at one end and the block is at a distance L from the fixed end. The ruler is rotated about the fixed end in the horizontal plane through the fixed end. Okay, so there is a ruler, one end of the ruler is fixed and other end is, there is a block is kept on the other end, and the block is at a distance L from the fixed end, and it is made to move circularly motion. Then what can the maximum angular speed be for which the block does not slip? The block should not slip. The block should not slip. Slip means, see, just like a turning of the vehicle and the curved path. The same thing is here. Okay. So there should be a force, like frictional force should be there to provide centripetal force. So the block should not slip in such a way. The angular speed, what should be the angular speed so that the block should not slip? Okay. So the condition is the frictional force should be applied in such a way that it should provide centripetal force. Okay. Yeah, this is the situation actually. Ruler is there and there is a block. Okay. Left side mu mg, right side centrifugal force. Upward normal force, downwards mg, and it is at a L length. So in order to not to slip, your frictional force should be equal to centripetal force. Okay. Frictional force should be equal to centripetal force. So you have to Find out omega 1. That's omega. Now next part of the question. If the angular speed of the ruler is uniformly increased from 0 at an angular acceleration alpha, what angular speed will the block slip? So what happens? What happens? So when you keep on increasing the angular speed, what happens? This block may slip from the ruler. This block may slip from the ruler at some particular uh, angular speed. So what is that angular speed they are asking? So this is what the clue. So the frictional force will be equal to square root of centripetal force plus this is L alpha, ML alpha. Okay, ML alpha. From where we got? Because um, the tangential acceleration is A, which is equal to L into alpha or R into alpha. There is a relation. Okay, tangential acceleration A is equal to R alpha. So from there we got this ML alpha. Here L is the radius actually. L is the radius.
Sir, I got answer for 21st question, sir.
This small l and capital L both are same only. Actually, I have written wrong. It's the same L only. Then you will get omega 2 if you simplify. Yeah. You see here we have done for various points three body diagrams we have done already at A, B, C, D, E. So this kind of pattern only we have taken curved path and we have solved it. And the same thing they are asking. Yeah. So at B, at C, at D, you see. So a track consists of two circular parts ABC and CDE of equal radius. So that is important, equal radius, 100 meter. And joined smoothly as shown in that figure. Okay. Each part subtends a right angle at its center. Each part subtends a right angle at its center. Let me also show this image. Okay, this is the path, and each part subtends a right angle at its center. So this one is right angle. This one is right angle at its center. So this is the center. Okay, and here this is the center.
Opposite.
Huh? And
I'm saying is sir.
And a cycle weighing 100 kg together with the rider travels at a constant speed of 18 km per hour on the track. Find the normal contact force by the road on the cycle when it is at B and D. Say at B and at D. At B and at D. So we have solved this. We have solved the expression for normal force. So please try to use those and solve it. I'll give 2 minutes. First problem 2 minutes. At B, normal
Sir,
force is mg
at
minus
D,
mv square by r. At D,
sir, at
normal force is
D,
mg plus mv square by r. Substitute all values.
sir,
You
sir,
will
answer 1025 newtons.
at B,
At D, sir.
At D, sir.
at D.
At B.
Okay.
Yes, sir.
At B,
It took be 975 newtons.
Yes, sir.
Very good. Okay. So at B and D, to use these expressions, you will get the answer. This is 975 Newton and this is 1000. At D, how much? 1000?
I'm just substituting.
Okay. The next, question number B. Question B, find the force of friction at BCD. At BCD. At BCD, no. At B and D, no friction actually. Okay. At C, frictional force is mg sin theta. M is there, G is there, but theta you have to find out. What could be the theta here? Frictional force at C, expression is mg sin theta. M is there, G is there. What could be the theta? So they have clearly mentioned here.
90 degrees, sir.
So B, C. It is just middle of it. C. So here the weight will make an angle of 45 degree at point C. So use that theta as 45, then you will get the answer.
Sir, at C is equal at C, force is
Huh?
7.7 Newton.
Okay, Maniritvika has got 707. Okay, fine.
Yes, sir, 707 newtons.
Okay. The next question, find the normal force between the road and the cycle just before and just after C. Just before and just after C.
Sir, formula mg cos theta minus n is equals to mv square by r.
Yeah, we have already done this.
N is equals to 707 minus 25. That is equal to 683 newtons.
Wait. Before crossing the C, what is the formula?
mg cos theta minus n is equals to mv square by r, sir.
Little bit louder, please. Abhiram, please be louder.
Sir, mg cos theta minus n, that is equals to mv square by r. Before crossing the C.
Before crossing, just you tell me the expression normal force. N is equal to how much? N formula. Mg.
No, mv square plus mv square by r plus mg cos theta. N is equals to.
Okay. Then after crossing the C, actually we have already solved it. This question. So this one only. And it is moving upwards. Yeah. That means after C, expression is mg cos theta minus mv square by r. And yeah, this one we have solved. Sliding up or sliding, yeah, sliding up mg cos theta minus mv square by r. That means after crossing C, this is the equation, normal force. And before crossing the C, then the n will be mg cos theta plus mv square by r. Okay. So use that expression, find the answer. Before C 682 Newton, after C 732 Newton you should get.
Sir, before 683, sir.
Oh, okay, fine. That means before C expression is mg cos theta
Minus mv square by r. After C, mg cos theta plus mv square by r.
oh,
Before
okay.
means minus, sir. After means plus.
Yeah. Okay, then next D. What should be the minimum friction coefficient between the road and the tire, which will ensure that the cyclist can move with a constant speed? Frictional coefficient they are asking. Frictional force F is equal mg sin theta, and that only you equate with mu n and find out mu value. That gives you the answer. Next question. In a children's park, a heavy rod is pivoted at the center and is made to rotate about the pivot so that the rod always remains horizontal. Two kids hold the rod near the ends and thus rotate with the rod. Okay, mass is given, mass of each kid 15 kg. Distance between the points of the rod where the two kids hold it be 3 meter. So radius, it is a radius actually. Suppose that the rod rotates at the rate 20 revolution per minute. Find the frictional force. So frictional force is nothing but, in order to turn, there should be centripetal force, and frictional force exerts a centripetal force. So if you find out centripetal force, you will get the answer for frictional force. So 24, a hemispherical ball of radius r is rotated about its axis of symmetry, which is kept vertical. A small block is kept. See, a hemispherical ball. You have to imagine a hemispherical ball, and there is a block. So this is what you see. So hemispherical ball, and there is a block, and it is rotating. It is rotating. Small block kept in the ball at a position where the radius makes an angle theta. Okay, radius makes an angle. So this is the radius vector. So this one, this should be straight line actually, dotted you see, and dotted line making an angle theta. Okay, dotted line. And the next, the block rotates with the ball without any slipping. The friction coefficient between the block and the ball surface is mu. Find the range of angular speed. Range, that means minimum angular speed and maximum angular speed, so that it will not slip. Okay. So for minimum angular speed, see here, this is a block. Try to understand this free body diagram. And mg downwards, mr omega square outwards, and so resultant of these two is some Fr, resultant of these two forces Fr, and Fr makes an angle pi. Fr makes an angle pi with this radius, and this mg makes an angle with this radius theta. So you apply. So this is, if this total angle is theta and only Fr and this radius is pi. So remaining angle will be theta minus alpha. Sorry, theta minus pi it should be. Oh my god. Not theta minus alpha. It is theta minus pi. Theta minus pi. I will correct it and I will share it again. Theta minus pi, and that theta minus pi, if you apply tan theta, opposite by adjacent, opposite by adjacent, opposite force is mr omega square and adjacent force is mg. So that is what I have done here. Tan theta minus alpha, tan theta minus pi is equal to mr omega square by mg. Okay. Gyandeep, any doubt?
No sir, no doubt sir.
Yeah. So in the trigonometry there is a formula tan a minus b. Tan a minus b formula is tan a minus tan b by 1 plus tan a tan b. So if you use that, tan theta minus pi, tan theta minus tan pi by 1 plus tan theta into tan pi. So if you simplify, you will get omega. Like you have to substitute tan theta is equal sin theta by cos theta. Okay, or tan pi is equal sin pi by cos pi. So this kind of formula you have to use, and you simplify, you will get the minimum angular speed. Okay, and to get the maximum angular speed, you have to just take theta plus alpha. Tan theta plus pi. Tan theta plus pi you have to take. It's not alpha. Tan theta plus pi you have to take. If you take that, tan theta plus pi if you take, then you will get the maximum angular speed. Again you have to simplify. Tan a plus b formula you have to use, and tan theta formula sin theta by cos theta, tan pi formula sin pi by cos pi, like that you have to use. You have to simplify, you will get a maximum angular speed, and that is only the range. Minimum to maximum is the range of angular speed. That is the answer.